Okay, this is the Arithmetic Series notes. And we're going to start with this. We're going to start with just the definition, super simple. An arithmetic series you can read, but I'll read to you anyway. The sum of all terms in an arithmetic sequence. So the arithmetic sequences we did in the last notes, that's just a pattern of numbers where it's adding or subtracting. Now what we're going to do is we're just going to add however many of them together. All right? Even for those of you that don't write down the notes, I do want you to write down one thing, okay, that we're going to use a few times this year. The word series is related to adding up numbers in a pattern. Okay? So the word series, anytime you hear that word this year, I want you to connect that with your adding a bunch of numbers together. Okay, so however you want to write that. But series is adding all the numbers together. Okay, so this is my formula for arithmetic series. Like if I ask you to add the first 450 terms of a series, that would really suck to add 450 things together. So instead we're just going to use this formula. This formula works great. It always works. So we're just going to plug in three things. The blue part here, this is just the number of terms that I'm asking you to add. So that could be 450. A sub 1, you already know, is the first term. A sub n is whatever the last term is. So let me ask you this. If I tell you to add the first 450 terms of a sequence together, is A sub n guaranteed to be 450? No, it's probably not actually. Whatever the pattern is would make it something different. So this would be A sub 450, which could be any number. But we have to add that 450th number to the first number and then multiply by this. Okay? I'm going to do sigma notation last. We may even hold that till tomorrow. Just know that sigma notation looks a lot more confusing than what it actually is. This E-looking thing is a Greek letter called sigma. That's why it's called sigma notation. And in math, it means to add a bunch of crap up, so that's why we're using it in these notes. Okay, example 1, I love the Gauss problem. Here's what you need to know about the Gauss problem. This is going to be the one thing you remember, and for the rest of the year, when we're going back and we're reviewing arithmetic series, I'm always going to refer to the Gauss problem because that's going to be what you remember. All right, let me tell you about a guy named Gauss. Okay, one of the greatest mathematicians of all time. Lived a super long time ago. I don't remember how long ago. But he was one of the best mathematicians, did a whole bunch of great, amazing things in math. He was German, for what it's worth, okay, and he was brilliant. So when Gauss was in 3rd grade, he showed up to school one day, and his teacher was hungover. You know what that means?
Yeah.
That means that the teacher was drunk the day before, and then felt like crap that day. Okay? Sorry, just in case anyone didn't know, that's what hungover means. And so terrible teacher, right? That's not a good thing to do as a teacher. But anyway, I'm not going to judge. So what the teacher did when he was hungover and feeling like crap, he wanted the kids to just leave him alone for a couple hours so he could like take a nap and chill. So he assigned this to all of his 3rd graders. He said, I want you to take all of the numbers between 1 and 100 and add them together. So 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15, and go all the way to 100. He thought the kids would leave him alone for a couple hours. Gauss turned the answer in about 30 seconds. And the teacher was like, what? And it was right. And here's what Gauss did, and it relates very well to what to arithmetic series. Okay? Gauss just looked at the numbers to start with. Oops, here, press this. Come on. Okay, so there's all of the numbers between 1 and 100. Obviously, I didn't write them all out. But Gauss realized this. You can add the numbers in any order. So he added the first one with the last one. Instead of doing 1 plus 2 and then plus 3 and then plus 4, he added the first one and the last one. Okay, and that was 101. Okay, then he added the second one with the second to last one and got 101. And when he added the third one with the third to last one, he got 101. It's all the pattern. And now it's pretty simple. How many pairings are there going to be? 50, right? There's 100 numbers. 1 pairs with 1. There's going to be 50 pairings. So all he had to do was multiply 50 times 101, and he got an answer of 5,050. And that is the correct answer to adding up the first 100 numbers together. Questions?
3rd grade math teacher just got right.
Okay, now, eyes up front. I want to relate this to the formula, and I want you to understand that the formula is this exact same thing. Okay, the formula goes like this. if we can go back to red, a sub n equals n over 2. Okay, n was the number of terms, correct? So that would be 100 over 2 times the first term was 1, the last term was 100. And that's what Gauss did. Adding the first and the last gave him that 101. And you know that that's going to be every single pairing in between. So what you just need to do is take the number of terms divided by 2 because that's how many total pairings there's going to be. This formula always works. Okay? So it's just the same thing here. We end up with a sub n equal to 50 times 101. So we know that it's going to equal 5,050. Yeah, I think he's smart.
You didn't have to do this.
All right, so let's apply the formula to example 2. I'm going to write the formula out to start, and I put a sub n over there. Normally we do s sub n. The s is just referring to a series. Okay, so the formula is n over 2 times a sub 1 plus a sub n. By the way, I think I told you this before. This year, and Bishop's going to be mad at me for this, but this year I'm not going to force you to memorize formulas. In the past, I always force my students to memorize them. I'm actually going to make you a nice like laminated formula sheet with a bunch of formulas on it, so you have that for tests. Sorry, Bishop. All right, so now let me plug in. I'm going to do s sub 40 because it's asking me to find the sum of the first 40 terms. All right, so that means there are 40 terms, so I'm going to have 40 over 2. Okay, times a sub 1 is easy to find. It's 4, it's the first term. Plus, a sub n I do not have yet, but I can find it. I'm going to do this. I'm going to write down that 13 is a sub 4, kind of duh, right? That's the fourth term. And I need to know what the 40th term is, which is going to be somewhere out there to the right. Okay, so to get from a sub 4 to a sub 40 is how many steps? 36 steps. I also can look and pretty easily see what's happening each step, correct? If I look at my pattern, 4, 7, 10, 13, it's clearly increasing by 3. So if I increase by 3, 36 times, that's going to be 108. So I'm increasing by 108 from there to there. But what I have to do, what everyone forgets, is to add that 13 also. So 108 plus 13 is going to be 121. So in my formula here, I've got 4 plus 121. All right, so now it's just a matter of simplifying. This is going to be 20 times 125. So this equals, help me out, I think it's 5,000 something. Someone do it for me real quick. It's not like we're in a hurry because I'm filming a video or anything.
2,500.
Say it again?
2,500.
Wow, it's way off. Okay, 2,500. Thank you, Mike. And that's it?
Why is this one so much easier?
Say it again?
This is so much easier.
It is easier. And essentially the reason it's so much easier is because you're just using a formula.
So why does math?
You just need to figure out what numbers to put in the formula, and the formula does the work for you. And that just goes to my point, the idea that if
Tell me why math.
I have less problems on this assignment because it's going to be easier. I try to make the number of problems match however many it is.
It's literally 10. Why does math go hard? Hard easy.
It's like a roller coaster.
Yeah.
Okay, let me, do I have time to do this last one? I think I do. And then, okay, so let me do this example 3. Okay, sigma notation. Eyes up front, this is new, you've never used this before, sigma notation. The only thing I've got to teach you right now is this new notation, the new way of writing things, okay? And it's not, it looks harder than what it is, all right? On the bottom here, this tells you the first term. It usually starts with n equals 1 because the first term is usually the first term. But if for some reason I wanted you to add up 40 terms in a pattern, but not the first 40, if I wanted you to add up the 5th term through the 45th term, then the bottom here would say n equals 5. So are we clear what I'm saying? That's just telling you where to start in the pattern. Usually it's n equals 1 because we usually start at the beginning. Is the first term 1? No. That's just telling us that it's starting with the first term. We just don't know what it is yet. Okay? Any guesses what the 26 means?
That's how many
That's how many numbers there are. So you are going to add up all of the numbers between the first term and the 26th term. Okay? You're going to add up all the numbers between the first term and the 26th term. That's how you read this notation. Is the 26th term 26? No. Maybe, but probably not. Okay? We're adding up all of the terms between 1 and 26. All right, now, to the right here, this parentheses in this little formula, this tells you how to find each term. Okay? So I'm going to show you how to do it. Obviously, in order to use the formula, I need to know the first term, correct? So one of the things I'm going to do is I'm going to find the first term. To find the first term, we plug a 1 in for n. So a sub 1 equals -4 times 1 plus 3. -4 times 1 is -4, plus 3 is going to be -1. My first term is -1. Should I find the second term? I would argue no. Why do I not care about the second term? Halima, great job. Everybody hear this. The reason I'm not going to waste time finding the second term is the formula doesn't need the second term. The formula that we're going to use to add all these numbers together, I need the first term and I need the last term. So the next term I'm going to find is going to be a sub 26. Because that's going to be part of my formula. So how I find the 26th term is the same way I find all the terms with sigma notation, is I plug 26 in for n. So -4 times 26 plus 3. Someone with their phone out, I need help. I need to know what 26 times 4 is, unless you do it in your head. 104 maybe?
Yeah.
104? Okay, so this is going to be -104 plus 3, which is going to equal -101, I believe.
What?
Am I wrong?
No.
I think I'm okay. All right, so now, I think I have enough information to plug into my formula, so I'm going to come over here to the right, and I'm going to write my formula first. I'm going to use S. Okay, so S of, how many terms are there? 26, right? My sigma notation told me we're adding up all the numbers from the first term to the 26th term. So I'm going to do S sub 26 equals, and I can see the formula up above, so I'm just going to start plugging in. N is the number of terms, so that's 26 over 2 times the first term I figured out is -1 plus the last term is -101. Okay, so I've got S of 26 equals, that's going to be 13 times -102. And I need help from one of your amazing calculators. -1,326. So what I've just done is I said, okay, from the first term to the 26th term, I didn't figure them all out. I just figured out the first and the last because that's all the formula needed. Okay, if I added up all of those numbers, it would give me -1,326. And that is it for these notes.